probability in genetics. Now, probability. Of course, you know, when we talk about probability, we are talking about chances, right? Chances of something occurring, is it not? In probability, we are making some predictions, and the rules, the principles of probability in genetics are: number one, we say this what? Multiplication rule. Multiplication rule. And multiplication rule, you also see it as independent events rule. Now, independent events are events that can happen without influence on another event. Events that can happen on their own without interactions, if it was gene interaction we're looking at. Now, when two events can happen on their own independently, not depending on another event, you use the multiplication rule. And the multiplication rule, you can always know when to use multiplication rule if you spot and in a statement, in the equation. So take note of this. For example, if you have something like, if you have a equation like, what is the probability that rain will fall today and my first child will be a male? It means you calculate the probability of rain falling today and the probability of my first child being a male, right? And you multiply them together. Do you understand? Yes. So, two independent events occurring, the probability, you use multiplication. And equations, they always represent that by using what? And. What is the probability of my first child being a male and my second child being a male? I use times multiplication, right? Yes. And is used. But the other way around, the second principle is addition rule. In addition rule, if we see mutually exclusive events are events that if one is occurring, the other one cannot occur. For example, rain cannot be falling now and sun will be shining now to light. I knew that. Okay, I cannot give birth to a boy now. It's supposed to say I'm not feeling fighting. You cannot give birth to a boy now, and that boy still becomes a girl. Okay, it's possible. And you are looking at two mutually exclusive events. That one can occur, or the other one can occur. In that case, use addition rule. This is what I mean. You can easily spot that in a statement where you see or, questions where you see or. For example, what is the probability that my first child will be a male or will be a female? Or, so anytime you see or in a equation, you add, right? You add the two probabilities. If you see and, you do what? You multiply. The third principle here, we are going to use all these principles in calculation. The third principle here is principle of what? Conditional probability. And when they say conditional, it means it's depending on something, right? Yes. It's depending on something. Now, previous events, something have happened before. But one thing you should note here is something that have already occurred cannot affect an event yet to come. We are going to see this more as we go on. But the question I gave you, good. Please pay good attention to this question. What is the probability that a heterozygous, first of all, heterozygous brown-eyed couple will give birth to a blue-eyed girl. Now, heterozygous, let's use B for the alleles. So, what will be the genotype of the couple? Capital B, small b, right? Capital B, small b.
Yes.
And what is the probability that heterozygous brown-eyed couple, meaning both of them are heterozygous, right?
Yes.
Husband and wife are heterozygous. So if we cross this, that's the first thing we do. We have to cross it. And in the crossing, you can decide to use your normal crosses or you use your what? Punnett square. I talked about Punnett square. We created Punnett square last class. But if you're not there, I recorded the class. I'll send the video. It's on my channel now. I'll send the link to the group after this class. So now, this is, let's use the Punnett square. In Punnett square, it's just like a box. Now you just distribute the alleles, you segregate, so you just separate these two. So this is capital B, small b, right? You write one capital B here. You write the small b here. You come to this other one. You write this capital B here. You write the small b here, right? Then you fill in the box. Here we are having capital B, right?
Yes.
You write it here. Here you have capital B, small b, right? Is it not?
Yes.
So capital B, small b. Here you be having capital B, small b, right?
Yes.
And here you be having what? Small b, small b. Do you understand this?
Yes.
If you do your normal cross, you still get the same thing. So these are our offspring. Now, the question says, what is the probability that the heterozygous brown-eyed couple will give birth to a blue-eyed girl? Now, these are four occurrences, right? These are four offspring we've got it. Is it not? Now, how many of them in this place have the phenotype brown eye? Three of them are brown eyes, right?
Yes.
And how many of them have blue eyes?
One.
Only this one, right?
Yes.
Because that dominant allele, capital letter B, is not there.
Yes.
So this one is blue eyes. Why the other three are what? So what is the probability of having blue eyes? 1/4. And if it is OBG, 1/4 will be an option, but it's wrong. Because the question says, what is the probability that a heterozygous brown-eyed couple will give birth to a blue-eyed girl? What if that one is a boy? So you have to find the probability of being a girl and blue-eyed. Do you understand? Let me get that again. Now, listen up. You write now. The probability of blue eye is what? 1/4, right? So the probability of blue eye is 1/4. But that's not all. They said blue eye girl. I know it's either you are a boy or you are a what?
Yeah.
And what you should know is sum of all possible occurrences is equal to what? 1. So the probability of being a boy plus the probability of being a girl should be equal to what? 1, right? It means the probability of being a boy is half, right? Is it not? The probability of being a girl is also what? Half. 1/2. So now the probability of being a girl is equal to what? 1/2. Now the question again. What is the probability that a heterozygous brown-eyed couple will give birth to a blue-eyed girl? Meaning that the person is a girl and blue eyes, right? Did you say the person is a girl or blue eyes? Did you say or blue eyes? The person is not a girl or blue eyes. The person is a girl and the person has what? Blue eyes. So that and there should tell you it is what? Multiplication. Remember the and rule. So in this case, the probability of the child being blue eyes, let me use B for blue eyes, and a girl is equal to what? 1/4 times what? 1 over 2. Hope you all know why we're using times. So 1 over 4 times 1 over 2 give you what? 1 over what? 8. And that's our answer. 1 over 8. The question says, suppose a couple just got married and planned to have 3 children. How many children? 3 children. What is the probability that all 3 will be boys? Now, what is the probability that the first one will be a boy? Okay, so let me call the probability of the first boy, the first child being a boy, as B1. So the probability of the first child being a boy is what? 1 over 2, right? What is the probability that the second boy will be a male?
1 over 2.
Second boy will be a male. What is the probability that the second child will be a male? 1 over 2, right?
Yeah.
What is the probability that the third child will be a male?
1 over 2.
1 over 2, right?
Yeah.
Now, what is the probability that the first child and the second child and the third child will be a male? Remember, and, right? Because they say all 3, meaning that the first and the second and the third are all what? Boys. So the probability, we now use the multiplication rule, right? Because we are using what? And. So that will be the probability of all 3 will be equal to what? 1 over 2 times what? 1 over 2 times what? 1 over 2. Is it not? 1 times 1 times 1 is what? 2 times 2. 4 times 2.
8.
That's it. See me after the class. What's your math number? Alright. If a couple is heterozygous for both sickle cell anemia and sickle fibrosis, what is the probability that they will have a child with either or both affliction? There are 2 questions there. So you have to find the probability for them having either affliction and the probability of them having both affliction. Now, let's look at it. They say the couple are both heterozygous for sickle cell anemia, right? And remember, in blood grouping, AA, AS, SS, which one is sickle here? SS. Is this heterozygous? No. This is homozygous, right? So this is the heterozygous, is it not? So AS is the heterozygous. So both couples are heterozygous. AS, both of the couples are AS. Heterozygous for sickle cell anemia. Sickle cell anemia is a disease that if you are not homozygous of it, you cannot express it. If you are heterozygous, you are a carrier. That's why they call this one carrier, because they are carrier of the sickle cell allele. But they cannot express it, because for you to express it, you must. Do we have any AS in this class?
Yes.
We have AS and you are normal. Are you not normal?
I am.
You are normal. So AS, they are carriers, and this is the heterozygous we are talking about. So let's calculate the probability now. If let's use Punnett square, or we use Punnett square, but let's use the normal course. If the husband is AS and the wife is AS, heterozygous, if we cross this, hello. So my mind was off on this one. Start again. Do you understand? No. So in this case, all you have to do is, since both couples are heterozygous for sickle cell anemia and sickle fibrosis, first, heterozygous for sickle cell anemia is actually AS. AS, because AA normal, AS heterozygous for sickle cell anemia carrier, and SS sickler, right? Now this is the genotype of the husband and that of the wife. If we cross this A and A will give us what? A and S will give us what? S and A will give us what? You said that S will be there. S and S will give us what? SS. Now for the sickle fibrosis, let's use C, letter C to represent that. And you can use, in this case, you can use any letter. This one, Even if you don't use, but this is standard. But if you use any other letter, you still get the right thing. Just know if heterozygous means one is capital letter, another one is small letter. Now, cystic fibrosis, I'll use C. So the husband, they are both heterozygous, right? Yeah. Meaning capital and small, is it not? Capital and small. So if I cross this, here will be what? Capital, right? Yes. This to the small one, capital, small. This to this, capital, small. And this to this, small, small. Now, back to the question. What is the probability that they will have a child with either or both affliction? First of all, what is the probability that they will have a child with sickle cell anemia? In this case, what is the probability that you have a child with sickle cell anemia? How many do we have here? This is the only child that we have sickle cell anemia, right? Yeah. Is it not? Yeah. So the probability here, probability of sickle cell anemia is equal to what? 1 out of how many? 4. So 1/4, right? Good. Yeah, what is the probability that you have cystic fibrosis? Only 1, right? Out of how many? Out of 4. So 1/4 too. Now, the question is, what is the probability that they will have a child with either or both affliction? Now, either meaning the child can have sickle cell anemia or right? Guys can have this one or this one. That is what either means, right?
Yeah.
Is it not? Then both affliction meaning the child have this one and this one. Is it not? So the probability of either sickle cell anemia or cystic fibrosis, I'm using F, will be equal to what? The probability of what? Sickle cell anemia, is it plus or? Why is it plus? Or plus the probability of what? Cystic fibrosis. So this will be equal to the probability of sickle cell anemia is what? So 1/4 plus the probability of this is what? So 1/4 plus 1/4 give us what? This is not 1/8. Now in this case, in fact the denominators are the same, so you just add the numerator. Which will give us what? 2/what? Is it? No. The normal way you solve this, just look for the LCM. The LCM is what? 4. 4 divided by 4. 1 times 1. Plus 4 divided by 4. 1 times 1. So the answer will be 2/what? Which is same as what? So the probability of either sickle cell anemia or cystic fibrosis is what? 1/2. Now, hello, we are not done. The second part of the question, the probability of both S and F will be equal to the probability of this. That's 1/4 times, right? Because you're looking at this and so 1/4 times what? 1/4, which will give you what?